Hopefully I'm audible. And you see the first poll question displayed on. This is very simple question, but unfortunately, I students are making the common mistake. Those 40% who have answered it incorrectly, they were absent yesterday. Physically, they might have present, but absent. Okay, and also they had watched the videos which were shared with you by Professor Murukar. So please utilize the efforts which we are taking, both in the form of videos which are being uploaded for your benefit, as well as the online classes. Okay. So this is very interesting course, and it's very conceptual too. Not straightforward when you read and you understand. Okay. Good that, yeah, Darshan, understand that my voice is breaking. Very straightforward question. Whether the boiling point always for water is always 100 degrees. It is okay. So in the last lecture, I discussed this point that is not so. Water at standard atmospheric pressure, that is at 1.013 bar, is 100 degrees centigrade. If we change the pressure, the boiling point of water changes. And I had said that instead of using the term boiling point, we would be using the term saturation temperature. The saturation temperature of water is 100 degrees centigrade when the pressure is standard atmospheric pressure, which is 1.013 bar. But if the pressure deviates from that, if it becomes lower or higher, accordingly, the boiling point would change. Okay. So the answer which students who have given this answer as 36% of the students, they are wrong. Correct answer is false. Answer is false. So the related question, let me hide this and let me go to the second poll question. So again, this is very simple question, straightforward question, and hopefully now maybe the number of students who are answering it correctly would answer it in the right spirit. So let us collect the responses. Please be quick in So let me close this poll and show you the results. About 80% of the students have voted, and I'm closing the poll and I'm going to share the results. The question is, in pressure cooker, water boils at a temperature higher than 100 degrees centigrade. Whether this statement is true or false. So 74% of the students feel that this statement is true. About 1/4 of the class who is attending this lecture, is about 25 students feel that it is a wrong statement. Okay. So let me close this and share the results with you. So the majority of the students have answered it correctly. The answer is that in the pressure cooker, the water boils at a temperature which is higher than the normal boiling point. That is at 100 degrees centigrade. It is more than 100 degrees centigrade because the water is pressurized in the pressure cooker, hence the boiling point increases. So in the pressure cooker, the boiling point increases because the pressure increases and it is obviously higher than 100 degree centigrade. And that is the reason, I had explained it yesterday, that is the reason why the food cooks faster in the pressure cooker. Okay. Hopefully it is clear to you now. Okay. So the 25% of the students who have given this as wrong, they should note that with the increase in the pressure in the pressure cooker, the boiling point of water increases beyond 100 degrees centigrade. Okay. I'm hiding this and I'm going to the next question. So this is again the concept which I taught you in the last class about superheating. The question is, what is the superheated steam? So this is to check whether you understood. Super is the steam whose temperature is always more than 100 degrees centigrade. Whether the statement is true or whether the statement is false. Now, interesting, the question is find that making the I talked about the heating of water at the boiling point. Superheated. So steam becomes superheated. Okay. So heated. What is essential is not or not. Am I audible now perfectly? Kamlesh? Now, Kamlesh, whether am I audible? No, not yet. Now it is audible. Purushal is saying no. Shubham is saying no. अच्छा क्यों हो रहा है break पता नहीं. Because I have a range. There is a lot of noise. Okay. Now whether it is clear, Tushant? Okay. Kamlesh is saying now that I am audible. Okay. So let me go to the results. Okay. Thank you, Jay. Let me close this poll and show you the result. This poll, I find that majority of the students have made mistake. Okay. So this concept you need to understand it clearly. You see on your can you see the results on the poll of the poll? Just a worry. I sorted this issue, but just superheated steam. Hello, hello. Yeah, saturation temperature is a temperature. Uh, Aniket, am I audible now? Okay. Saturation temperature is a temperature uh, of is nothing but the boiling point. Okay, and I said that boiling point could be even 25 degrees centigrade. Okay, when can the boiling point be 25 degrees centigrade? Boiling point can be 25 degrees centigrade if the pressure is lower than the atmospheric pressure. Okay, you can have boiling at 30 degrees centigrade also. You can have boiling at 40 degrees centigrade also. So suppose the pressure is such that the water boils at 25 degrees centigrade and you continue boiling that, then if it reaches 30 degrees centigrade, it means that the steam would be superheated, right? So even at 30 degrees centigrade, if the boiling point is 25 and if the steam has reached 30 degrees centigrade, the steam can be called as superheated steam. So we should be the first lesson you should do take in the properties of steam is that you should have a total disconnect of 100 degrees centigrade from your mind. Okay, so you should forget that water boils at 100 degrees centigrade, which you are learned in the physics. What you should understand is water can boil at any temperature: 25, 30, 40, 50, 60, 70, 80, 100, 120, 150, depending upon the pressure. Okay, and because the boiling point can be anything, so it is not essential that the steam, for the steam to be superheated, the temperature has to be greater than 100 degrees centigrade, right? Is this clear? Is the point clear that the steam can be superheated steam even when the temperature is lower than 100 degrees centigrade, provided the saturation temperature is lower? Is this clear? Is this point clear or no? So I'm repeating this because 80% of the students have answered this question incorrectly. The correct answer is the false. Option is false. 19% of the students who have answered it as false, they are right. We should be clear that superheated steam. Okay, Gargi, I am repeating this again. Superheated steam. Okay, I will show you on the diagram also so that you will understand. Superheated steam means the steam whose temperature is greater than the saturation temperature, and saturation temperature can be anything depending upon the pressure. So it is not that the steam is at 105 and you call it as superheated steam. It's not that way. depends upon what is the saturation temperature. Okay, is this clear, Gargi? Depending upon the saturation temperature, Sharbari, yeah, sensible heating and superheating, you want the difference. Sensible heating means you basically increase the temperature. If you increase the temperature, it could be increasing without superheating also. Means I'll show you, this would be clear to you when I will draw the vapor dome. Okay, so just wait, Sharbari. You'll understand the difference between, just to answer you, superheating is always sensible heating, but sensible heating is not always superheating. Okay, I'll come to that point when I discuss the vapor dome. Okay, so just wait for a while, Sharvari. Just answer a few more questions which I have on the poll. I'm hiding this poll question and I'm taking the next question. Now the poll question is in front of you. During the heat transfer, during boiling, the temperature increases, the temperature remains constant. These are the two options. During heat transfer, during boiling, the temperature increases, the temperature remains constant. These are the two options. Please be quick in recording your responses because we have a short of time. The question is, please listen to the question carefully. Read the question carefully. During heat transfer, while the boiling process is happening, the temperature increases because the heat is being added, or the temperature remains constant. Okay. Only 53% of the class has voted. You should be very quick in recording, otherwise I'll be closing the poll. And please note that we get in our GoToWebinar app, we have an option of seeing who has voted and who is not voted, right? So you need to be very quick in recording your responses because that shows there is an engagement with the students. The students are involved in the teaching learning process. So the answer is, again, I see that some about 50% of the class has not understood this. What I had said in the yesterday's class, yesterday's lecture, that when you are talking about the phase change or boiling, okay, I'm closing this poll and I'm showing you the result. You see that the 45% of the students have made the mistake and 55% of the students have answered it correctly. The correct answer is, during boiling, in spite of heat transfer, the temperature remains constant. And why is that so? That is because the heat which is being transferred is utilized not for increasing the temperature, but for phase transformation. Okay, there is a phase transformation from liquid to vapor, okay, liquid to gas. When you are heating, so when you are heating that water, the temperature is not going to rise, but the heat which is being transferred is utilized for changing the phase. So note that during boiling, the temperature remains constant. Okay, I hope this is clear to you. During boiling, the temperature remains constant in spite of the fact that heat is being added. Let me go to the next question. Let me hide this and go to the next question. Now I hope that you have got hold of the steam tables. Okay, if you have got hold of the steam tables, you just answer this. If you have not got hold of the steam tables, then you should make sure that you have downloaded the steam tables online. So let me ask this question now. Try to answer this. This question is about boiling point of water at 10 bar pressure. It is asking boiling point of water at 10 bar pressure. Obviously, we see that I see some interesting responses here. Please be fast in giving your responses. I'll be closing the poll within a minute. The responses are not very encouraging. The responses are not very encouraging. The responses which you are giving me and which I am seeing on my poll results, I see that in spite of hammering you about the concept of boiling point, I see a sizable number of students making the same mistake, and that sizable is not a less quantity, it is greater than 40%. Okay, greater than 40%. So either the students are not attentive, they are watching some movie online while attending the classes, okay, or they are busy helping their mother in their household chores, okay, but whatever they are doing, they are not attentive, they are not bothered about listening to the videos, or they are not attentive in the online classes. So that is very serious, and that would have implications on your assessment. Okay, so please make sure that when you are missing some point, you go back to the videos, listen to them again and again, and see that your concepts are clear. So I'll be closing the poll and I'll be showing the results. Very interesting results I get. You see that I asked the boiling point of water at 10 bar. Obviously, after so many repetitions, I told you that with the increase in the pressure, the standard atmospheric pressure is about 1 bar. To be exact, it's 1.01325 bar. Okay, so at 1 bar, approximately the temperature at which the water is boiling is 100 degrees centigrade. So how come this 47% of the students who have given their polls, okay, they have voted, they are writing that the boiling point of water at 10 bar is 100 degrees centigrade. So that is totally unacceptable answer. 47% of the students saying that the boiling point of water at 10 bar is 100 degrees centigrade is unacceptable answer, because I repeated this again and again that we need to be very clear that boiling point is dependent upon the pressure. Okay, and the correct answer is the option 2, which is about 184 degrees centigrade. Chaitali is right. The boiling point is 184 degrees centigrade. So please note that the boiling point of water could increase with the increase in pressure. So some students, I guess that they have got hold of the steam tables. That is very good, and hence that 32% of the students who have answered it correctly, I'm assuming that they are having the steam tables with them. Okay. Now let me ask you another question, related question with that. Again, refer to your steam tables and get me the correct answer. The units are not given, but you assume that the unit is degree Celsius. In the poll answers, the unit is not given, but you assume that the units are degree Celsius. Degree Celsius. So now the responses are encouraging, but the number of students who have voted is so far only 30%. So be quick in recording your responses. I am giving some allowances for the speed, your bandwidth. So about 50% of the class have voted, and they see that the boiling point of water, there are 3 options given. One is 100 degrees centigrade, there is 311 degrees centigrade, and third is 211 degrees centigrade. So let me close the poll. Only 60% of the class has voted, and of that, again I see some insincere students who are about 20% of the students are insincere. Okay, this is shown from the poll results. I'm closing the polls and I'm sharing with you the results. Okay, so I'll be finding out from my poll results who are those insincere students, because those insincere students have marked the answer as 100 degrees centigrade. Okay, so you see there, I'm sharing the results. So you see that 22% of the class is insincere. They are watching movies and still they are attempting the polls. Okay, and about 58% of the students, they are sincere. They are having the steam tables with them, and they are figuring out the correct answer. So the correct answer is those who are who have given the answer as 311 degrees centigrade. Okay. So commonsensical thing is that when you increase the pressure, the boiling point is going to increase, and still this 22% students, they feel that it remains 100 degrees centigrade. So that is very surprising for us. Okay, not very encouraging sign. So let me hide this now and go to the next question. This is the final poll question. Yeah. Again, this is to check your understanding of what we had discussed in the last class. You need to be quick in voting. Only 20% of the students have voted so far. I'll give you another minute for you to find out the answer and give me the correct response. So just in the questions column, just write your name if you have the steam tables with you. The physical steam tables, okay, not the online ones. If you have got the physical steam tables, you say, you write your names and put your and say yes in the questions column. If you have got the physical copy of the steam tables, this is just to, okay, Gargi has got that physical steam table, the printed steam table. Deep Lakshmi also has the steam table. Why I'm asking you is that because then I would be able to also talk about the physical steam table with you. Kamlesh has got the steam table. So Gargi, Deep Lakshmi, Kamlesh, Parikshit. Only 4 students have the steam tables. Anamta also has got it. Gargi, Deeplakshmi, Kamlesh, Parikshit, and Anamta. They have the stream tables with them. Okay, so as you see, it means that only 4 students have got the stream tables copy with them. So my request again is that you try to get hold of, try to purchase the stream tables from the market. I'm sure they are available in the market. Okay, unless and until there is very, if you are staying at a very remote location, okay, outside some city premises, uh, I don't feel there is any difficulty in purchasing one. Okay, the shops are open, so try to get hold of the steam tables so that because all this understanding of properties of steam would be required not only in the second year and for the course of doing problems on properties of steam involving the vapor power cycles and boiler problems, but you will also require them in the higher classes. Okay, so it is a good idea to purchase one. Okay, or at least get a photocopy of that, which is not legal obviously, but if that is a problem, it's a good idea to purchase one. Okay, so now I had asked you about the latent heat of vaporization at 1.013 bar, and about 43% of the students have answered it correctly. It is about 2200 kilojoules per kg. Okay. Interestingly, let me share this with you, and you should laugh. Obviously, you can have it. Look at this 20% of the class who are busy watching movies. They are saying that latent heat of vaporization is degree Celsius. So I'd already told you that it is about heat quantity, and when you are talking about a heat quantity, it has to do with the units like joules or kilojoules and not degree Celsius. So when students are saying that latent heat of vaporization is 100 degrees Celsius, so obviously this 20% of the class, they are the least interested in this course. Okay, for whatever reasons, right? So that is the incorrect answer. So I am not going to forgive this 20% of the class. Okay, but I would tolerate this 36% who are giving 1000 kilojoules per kg as answer. Okay, but the correct answer is obviously coming from this 40% of the class, which is saying it is 2200 kilojoules per kg. What is latent heat of vaporization? We had discussed this, that latent heat of vaporization is basically the heat required for phase transformation. Okay, when the water gets converted to steam, the energy which is required for converting 1 kg of water to steam, that is called as a latent heat of vaporization. And this value of latent heat of vaporization again would differ with respect to the pressure. Okay, that you will see when you use the steam tables. If you look at the steam table and if you look for the latent heat values for different pressures, you will find that those values keep on changing. Okay, right? So with this polls, not very satisfactory poll results, I would continue with my discussion on the properties of steam. Okay. So in the last lecture, let me first share with you the screen. Okay. Let me hide this result first. Okay, the results are now not seen. And now I'm going to share with you the screen. Okay. So I'll just make somebody as a organizer. I'll make Pille ma'am as organizer, and then I'll come back and sorry, presenter, and I'll then try to show the screen. Okay. Okay. The screen would be seen, I guess, wet. Just a minute. Yeah. So now you are seeing the whiteboard, right? And let me discuss this uh, properties of steam with reference to the temperature enthalpy diagram. Okay. So I'm going to plot. This is the y-axis wherein I would be talking about temperature, and on the x-axis I'm putting the property of specific enthalpy. And I'm going to discuss what I had discussed yesterday. I had talked about heating at constant pressure. Okay. If you remember that, I had taken an example of a vessel. There is water in it, and the vessel, the water is at ambient temperature, and you continue heating. Okay. So initially it is at 25 degrees centigrade at atmospheric pressure. Okay. So what will happen next? If you heat it, the temperature is going to rise. Okay, I'm heating it at constant atmospheric pressure. Pressure is constant, and it is 1.013 bar. Okay, so if you heat it, the water's temperature will rise to 26, 27, 28, 29, 30 like this, and ultimately the boiling point would be reached. And you know that the boiling point of water at standard atmospheric pressure is 100 degrees centigrade. So once that boiling point is reached, if you continue heating, the temperature would remain constant now. If you continue heating, the temperature would remain constant. Okay. And this is what? This is liquid water. Okay, this is liquid water. That is, it is water here. And what is this process? Let us say suppose this is A, this is B, and this is C. So what is process B to C? Just answer me. What is the process B to C? What is the process A to B? Sorry. First, what is the process A to B? What is the process A to B? Shubham? A to B, A to B. Gargi, A to B process. Sensible heating. Yeah, Sharvari was having that question. Yeah, Neha is also correct. I guess Sharvari had that question of what is the difference between sensible heating and superheating, right? So Sharvari, I'm going to answer your question with the help of this diagram, right? So the process A to B is, as Gargi, Neha, and Sharvari are saying, it is a sensible heating, right? It is sensible heating. Jaya has also answered it correctly. Now, what is the process B to C? What is the process B to C? Kamlesh, you are wrong. Kamlesh, A to B is not superheating, Kamlesh. A to B is not superheating, Kamlesh. That is wrong answer. B to C is what? What is the process B to C? B to C is not superheating, Kamlesh. That is wrong. So Gargi has answered it correctly. Yeah, Vaibhav Deshmukh is correct. Evaporation, instead of using evaporation, we will be using the term boiling. So Pranav, you are right. It is boiling process. Gargi is right. It is a boiling process. And what happens to the temperature, Pranav, during B to C? Pranav, what happens to the temperature during B to C? Yeah, it is constant. And why is that constant? Why is that constant, Neha? Why is the temperature constant, Neha? You are adding the heat, no? The temperature is constant because, yeah, Gunjan, you are right. The temperature is constant because the heat is utilized for phase transformation and not for increasing the temperature. Okay, so there is a latent, it is hence it is called as a latent heating, obviously, right? So there is a phase change, and that is responsible for the temperature remaining constant. Okay, and now let us say B, and now let us say that the boiling has stopped. Boiling has stopped completely. Okay, so what is the phase at state C? What is the phase at state C? What is the phase at state? Yeah, Gunjan, you are right. Right. Kamlesh, you are right. The phase at state C is you have steam and there is no water. There is steam, but there is no liquid water. No liquid water. Okay. So that state C, as Kamlesh has wrote, and Yugandhara is also saying that it is a dry steam. It's called as a dry steam. Dry in the sense that it does not contain liquid water. Okay, state C is a dry steam, right? Now, if you continue heating, now this is a constant pressure heating, mind well, and I'm heating it at 1.013 bar. Okay, 1325 bar, right? Now, if you continue heating, if you still continue heating, what would happen now? What would happen now? Yes, Gunjan, you are right. What would happen now? The temperature would, what would happen to the temperature, Gunjan? Yugandhara? Ganesh? What would happen to the temperature if you continue heating? Yeah, it would increase. Okay, the temperature would increase, right? So, as all of you are saying, the temperature would increase. So, let me draw this. Okay, let me draw this. Let me draw this. Yeah, correct, Jay. So, let us say that you continue heating up to D. You continue heating up to D, right? So this is again constant pressure heating, mind well. The pressure is constant, right? Now let us talk about some phase C dash. Okay, C dash. So what is the quality of how do you describe the state C dash? What is C dash? See, B is liquid water, right? B is liquid water. A is also liquid water. A dash is also liquid water, right? C is dry steam. So what is C dash? Yeah, Neha, you are right. Kamlesh, you are right. Jay, you are right. C dash is a superheated steam. C dash is a superheated steam. Okay, right? So the process C to D is also sensible heating. So let me go to the question which Sharvari has asked. Yeah, Sharvari, no. Who had raised that question? Sharvari had asked this question. So Sharvari was asking what is the difference between sensible heating and Sharvari is asking what is the difference between sensible heating and superheating, right? So C to D is also sensible heating, mind well. A to B is also sensible heating. And C to D is also sensible heating. But C to D is a special type of sensible heating because during this sensible heating, the steam becomes superheated. During this sensible heating, the steam becomes superheated. Okay. So C to D is superheating of the steam. So this is superheating of the steam, right? So superheating means what? You are heating the steam beyond the boiling point. This C, temperature C is equal to temperature B is equal to the boiling point is equal to the boiling point, or it is also called as a saturation temperature. So when you heat the steam, the process C to D, this process C to D is heating of the steam, okay, beyond the boiling point, beyond the saturation point, beyond the saturation temperature, and this process C to D is called as superheating. Am I clear now? What is superheating, Sharvari? Sharvari, am I clear? What is superheating? Vikyat is clear, is saying he is clear. Vikyat, Shubham, Aniket, am I clear now? Rushali, have you understood what is superheating? Anybody who has not understood what is superheating? Okay. Sharvari is saying she has understood. Sushant has understood. Kamlesh has understood. All right. So now let us talk about. Yeah, Rushali is understood. So let us now give some names to this. Okay. So I would now we are talking about enthalpy. I am denoting this enthalpy, specific enthalpy, by small h. Okay. So this h now let me go to a question. What is the difference between the state A dash and state B, or state A and state A dash, and state A dash and state B? What is the difference between state A dash? What is the phase at A dash? What is the phase at B? What is the phase at A dash and what is the phase at B? Any answers? What is the phase at A dash and what is the phase at E? A's, sorry. A dash, A and B. Anybody from you? The phase at A dash is liquid water. Phase at B is also liquid water. Phase at A is also water. Neha. Phase at A dash is also only water, and phase at B is also only water. Now temperature is different. That is correct. I am talking about phase, Kamlesh. Neha, are you getting the point? Phase A dash, B, they are all water. They are all water. Okay. Now, how do I differentiate between B and A dash? So the difference between B and A dash is what? The difference between yeah, correct, Kamlesh, you are right. So B is the point where the phase, as Kamlesh is writing, the beginning of phase change would start. Okay. The beginning would happen of phase change. So the phase change is going to start at B. So I would say, in simpler terms, I would say, no, Kamlesh, it is not critical point. Please listen to the videos carefully about critical point which Professor Murukar has made. You are mistaking about it. You are not understood critical point. B is not critical point. B is the phase when the water is about to boil. Water is about to boil. About to boil. The boiling has not started. It is now about to boil. So when you add the heat, it will start boiling, right? So that B is called as saturated water. B is not a critical point. B is the boiling point. It is not the critical point. Okay, the temperature B is the boiling point. Kamlesh, have you understood? It is not the boiling point. It is not the critical point. It is the boiling point. And the state B is called as saturated liquid, or in the case of water, it's called as saturated water. So how do you define saturated water? Saturated water is the water which is about to boil. Very simple definition. It is, and whether A dash is about to boil, whether A dash is about to boil, whether A dash is about to boil, yes or no? No, right. Neha is right. Whether A dash is about to boil, no. Sharbari, you are right. Whether A is about to boil, yeah, Gunjan is right. So A dash is not about to boil. Now, what is the temperature of A dash? What is the temperature of A dash or A? Generically speaking, in general terms, what is the temperature of A dash or A? Yeah, correct, Gunjan, you are right. It is less than the saturation temperature. So I will be using the term saturation temperature instead of boiling point, which is also correct. So A dash and A means the liquid is at a temperature below the saturation point, and this phase A dash A, it is called as subcooled liquid. It is called as subcooled liquid. Have you understood this? Subcooled water. In this case, it is not any liquid, it is water. So have you understood what is subcooled water? Have you understood what is subcooled water? Subcooled water means subsaturated water. Subcooled water means subsaturated water, right? So what is subsaturated water? Subsaturated water means the water, subsaturated water means the water which is subcooled, or subsaturated water means the water whose temperature is less than the saturation temperature. Are you getting this point? Whether you understood this, what is subcooled water? Hopefully you understood this. Okay. Now let us go to naming the point C. Okay. So naming the point C is one name is called as dry saturated, dry steam. Okay, but instead of dry steam, I would again add one more adjective to it, just description. It's called as dry saturated steam. State C is called as dry saturated steam. And how do you define dry saturated steam? So dry saturated steam, if you heat it, it is about to superheat. If you heat it, it is about to superheat, right? Okay, suppose you cool this. Suppose you cool this dry saturated steam. What would happen? Suppose you cool the dry saturated steam. What would happen? Any answers? If you cool the dry saturated steam, what would happen? Acha. In other words, if I am saying B to C, what is B to C? What is the process B to C? What is the process B to C? Boiling. Correct. Sharvari is correct. Right. Jay, you are right. Now, what is the process C to B? What is the process C to B? Correct. Kunal, you are right. C to B is not cooling. Gunjan, it is not cooling. It is condensation. It is condensation. Okay. C to B is condensation. So we can say that if you remove certain heat, okay, let us say that the steam is at a dry saturated state. So if you cool it, if the steam is at dry saturated state and if you cool it, then the steam would start condensing. So we can say that the state C is the state of steam which is about to condense if you remove the heat. Are you getting it? So what is dry saturated steam? Dry saturated steam is a steam which is about to superheat if you heat it at constant pressure, or it is the dry saturated steam is a steam which is about to condense if you remove the heat at constant. So now I have introduced to you three terms. One is called subcooled water or subsaturated water. What is subcooled water or subsaturated water? What is subcooled water or subsaturated water? Krushali, what is subcooled water or yeah, Gunjan, you are right. What is subcooled water? Krushali, Yash More, Yuvraj Singh. What is subcooled water? Yuvraj Singh. Yuvraj, you are around or you are dreaming? Yuvraj Singh, Yugandhara Sohane. See, I don't want the regular students to answer. Okay, I want the students. Deshmukh, what it is in generic terms, Deshmukh. Yuvraj Singh is not there. Yugandhara Sonona is absent. Akanksha Salamke. Yes, you are right. Akanksha, you are right. Akanksha is right. See, I want some other students also to answer so that it would give me some satisfaction that not only some 8 to 10 students who are active on this online mode, they are understanding. I want to ensure that all of you understand. Okay. So I want now others also. Akanksha has answered. Thank you, Akanksha. Vaibhav Deshmukh has answered. Tanaya is there. Tanaya, Tejas Sanap, Utkarsh Kulkarni. See, when I'm reading out the names and if they are not answering, then the only possibility is that they are doing some other work. Okay, I don't see the answers coming from the students whose names have been read. Gauri Jagtap, Gaurav Nagre, Ganesh Jadhav, Durgesh Birari, Sheikh Kaif Sheikh, Mayur Salunke, Rishikesh Thorat, Anupriya Wadekar, Kunal Bhagwat, Avinash Aire, Atharva Pandit, Atharva Mahajan, Anish Patil. Why is that I'm not getting the responses? Gaurav, answer sang. You're there. That is all right. Tell me the answer, Gaurav. See, I'll repeat this once again, assuming that you have not understood. See, I'll be discussing this once again. I am discussing a temperature enthalpy diagram for steam, right? And I have considered the heating of water at standard atmospheric pressure. Okay. So if let us say that the water is at 25 degrees centigrade at standard atmospheric pressure, you know that the boiling point at standard atmospheric pressure is 100 degrees centigrade. So if you start heating that water at constant pressure, that water would first reach A dash and then finally it would reach B. This heating from A to B, that is up to the boiling point, is called a sensible heating of water, right? Now, how is the water at A different from water at B? The water at A is different from water at B because you see that the temperature at A is less than the saturation temperature, which is the temperature at B. Okay, so all these states, that is A dash, which you see on the diagram, they are at the temperatures below the saturation temperature or below the boiling point. So these states A and A dash, they are called as subcooled liquid, subcooled water or subsaturated water. Okay. The state B, what is the state B? What is the specialty of state B? State B is a state when the water is about to boil, right? Water is about to boil. When you start heat, when you continue heating. So that state is called as a saturated water or saturated liquid state. Now B to C is a process. B to C is a process wherein you are heating, but you are not experiencing any temperature rise. There is no temperature rise. Why is that so? That is because we are having a phase transformation. The water gradually converts itself to steam. Okay, so if you heat it, the water would start getting converted to gaseous phase, the liquid gets converted to gaseous phase. So B to C, progressively you will find that more and more gas is being generated, and finally at C you will find that no liquid water is left. No liquid water is left. That state C is called as dry saturated steam. If you heat that water, if you heat that steam further, what you will find is that now the phase transformation has stopped. The steam would now again experience sensible heating. The temperature of the steam would rise, and that sensible heating of the steam is called as superheating. It is called as superheating. So the now steam becomes superheated, meaning what? The temperature C dash or temperature D is greater than the saturation temperature. Temperature C dash or D, if you see the diagram carefully, it is greater than the saturation temperature or greater than the boiling point. Okay, so superheated steam is the steam whose temperature is greater than the saturated temperature, right? Is this clear? Now the steam which is between B and C is called as a wet steam because it will contain some liquid water always. Okay, and if you look at the state B, there is no gas, and if you look at the state C, there is no liquid. Okay, and midway you will find that there would always be some liquid and some gas. So there will be liquid and gas, and it is called as a wet steam. Okay, So what is wet steam? So wet steam is a steam which has certain liquid content, liquid water in it. Okay, it has certain liquid water in it. So now we have defined all the types of steam. We have defined all the phases. One is a subcooled phase or subsaturated phase, means the temperature is below the boiling point, below the saturation temperature. Then we are talking about saturated liquid or saturated water, means the water which is about to boil. We are talking about wet steam, means the steam which is having certain liquid fractions. We are talking about dry saturated steam, which means that it is a steam which is about to condense if you remove the heat, or which is about to superheat if you increase the temperature, if you increase the heating, right? And finally there is superheating. Okay, I hope this is clear to you. Hello. Okay, with this, I will be ending the session. Okay, thanks for being online.